Hey guys, welcome to today's class. In this video, we are going to talk about what limiting reactant and reactants in excess. So I'm going to explain the concept of what limiting reactants, so you understand what is limiting reactant and reactant in what in excess in what in chemistry. Then we are going to look at what things you need to look at when solving limiting reactant and reactant in what in excess. So those things you need to understand when you see question on what limiting reactant, how do you identify those questions and how do you solve it. Then we are going to look at what various example on solving what limiting what reactant and what reactant in excess. So this is the complete guide in what limiting reactant. So what I want you to do, so make sure you have with your pen and your notebook, also with your calculator, so I can follow through what I'm going to teach you. Get so by the end of this video, what you have to do is to what go to your textbook, go to the exercises and pick out similar question and solve for yourself, because this is the easiest way and fastest way for you to cover any topic in a short time. You get so by the end of this video, you don't need to worry about the limiting reactant and reactant in excess question again. What you have to do is to keep on solving and mastering the calculation. You get so let's get started. So now, what is limiting reactant? You may ask yourself. Limiting reactant is the reactant that is being used up during the course of a chemical reaction. Then reactant in excess is the reactant that remains when the reaction stops. Now I'm going to illustrate for you. Imagine here we have A plus B giving you what? C. Now A plus B is what is the reactant. We have two reactants here, and here we have what? Product. Right? Now, these two react together to form what is particular what product, right? Now, this one we have its own setting mass. We have your own setting mass. What produce what C. Two of them. Now the combination of the two of them that will produce C. You get so as the reaction continues, like as the reaction proceeds, it will get to a point where the reaction will stop. Now the reaction will stop not necessarily because the two of them has been used up, because one of the reactant has been what used up. You get now when one reactant is being used up, now there's no way C can be produced, so the reaction will stop. So the one that is being used up during the course of the chemical reaction is called the limiting reactant. Why the one that remains when the reaction stops called what the reactant in what in excess. You get I believe you get the concept now. So now let's take the first question here. Now it's that what mass of CO2 could be formed by the reaction was 16 grams of CH4 with 48 grams of O2. Now here's what is the balanced chemical equation. You get now the first you want to do here for every question that relates to what react masses, you want to write what the balanced chemical equation. Most times the balanced equation will be given to you in the question, but sometimes it will not be given to you. So if eventually the question is not given to you, it's now left for you to find the chemical reaction and balance it, right? But yeah, we're going to share our thing again. It has already been given to me, right? So when we look at it very well, now CH4 react was O2 to go produce CO2 and water. Now they are now asking if the mass of 16 grams of CH4 react was 48 grams of O2. What is the mass of CO2 that will produce here? You get so we are giving you two mass of the we are giving mass of the two reactants. So what you want to do here now, you want to use the mass of both reactants to produce the mass of CO2. You get so the least mass that is it produced is the mass of of CO2 produced. You get now I'm going to show you a simple method to solve this. Now with this method, you can know the limiting reactants, also know the reactant in excess, and also get the amount of CO2 that is being produced. Then I will advise to use this method or stick to the end of this video and understand this. You get so now let's look at it very well. So the first thing you want to do, you want to write this one out again. Here we have CH4 plus 2O2 giving you 2H2O plus CO2, right? So what I want to do here, I want to write the balance mass and the balance mole for this one, for every species. So here we have mole. And here we have what? Mass. The mole is very easy. How many mole do you have here? Here we have what? 1 mole. Right? Here we have what? 1 mole. Here we have what? 2 moles. Here we have what? 2 moles. Here we have what? 1 mole. You get? So how do you get the mass? The mass is very easy. Look at the molar mass of this one here and multiply by what? By the mass of mole. You get? So here we have CH4. How do you get the molar mass of CH4? Remember, the atomic mass of carbon is what? Is 12. 12 times 1 plus what? 1 times 4, right? Because the atomic mass of hydrogen is 1, then the mass of hydrogen is what? The mass of hydrogen is 4. So going to be what? 12 plus 4, which is going to be 16 gram per what? Per mole. It means that for every 1 mole of CH4, I have what? 16 gram of what? CH4, right? So how many mole do you have? Here we have what? 1. So 1 times 16, here we have what? 16 what? Gram. Hope you understand. So the next thing is what? O2. So how do you get here? Which O2? We're going to be what? 16 times 2. We're going to be what? 32 gram per what? Per mole. Right? 32 what? Gram per mole. Right? So how many mole do we have here? Here we have 2. So 2 times 32. Here we have what? 60 what? 4 what? Gram. Right? Next is what? Water. The next is what? Water. H2O. H2O, which is what? 1 times 2 plus what? 16 times 1. Let me give you what? 18 gram per mole. Right? How many mole do we have here? Here we have 2. So 18 times 2. Here we have 30 what? 6. So 18 times 2 times 18 is what? Here we have what? 36 what? Gram. Then here we have what? CO2. CO2 is what? It's 44 gram. Calculate it. So now let's calculate question again. So this is the first thing you want to do, right? Now for you to solve any reactive math question, this is the first thing you want to do. Now once you can do this one here, you are what? 50% done with what? With the question. You get. So now let's look at our question again. Now they ask you to what? Calculate what? The mass. So the goal is what? To get what? The mass of what? CO2. That's what you're actually what? Calculating, right? Now the mass of methane given is what? Mass of what? CH4 is what? 16 what? Gram, right? And the mass of what? O2 is given to me as what? 48. So mass of what? O2 is given to me as what? 48 what? Gram. So what you want to do here, you want to use what? The mass of what? Both of them to calculate from here. So how do you do that? So follow me closely because I want to give you some secret for you. Now with this method about tissue, you can get what? The limiting reactant, you get what? The reactant necessary, you can also get the mass of what? Of the product produced. You get. So that is why this method is key. Remember, we are calculating what? Mass of what? CO2. So mass of what? CO2. Write down what you are calculating. Now let's start what? With methane, which is what? CH4. So 16 gram of what? CH4 is what is given to me, right? So here we have what? 16 gram of what? CH4 over what? 1 times. Here we have a division sign here, right? So remember, you are using what? The mass of this guy here, which is one here, to calculate what mass of this guy, which is this guy. Right? So that means that 16 gram of what? CH4 equals what? 44 gram of what? CO2. Do that. Now because I'm looking for what? Mass of CO2. Now 44 gram of CO2 will now be at the top. So here I have 44 gram of what? CO2 will be at the top, right? Then this guy will be at the down. So here we have what? 16 gram of what? CH4 will be at the down. So you can see that 60 gram of CH4 will cancel out 60 gram of CH4, right? So what will be left is what? 44 gram of what? CO2. Now what does it mean? It means that 16 gram of what? CH4, 16 gram of what? CH4 produce what? 44 gram of what? CO2. That is meaning. So we are done with what? The first one. Remember, we have used what the mass of what CH4 to calculate what the mass of CO2, right? Now we are going to repeat the process for what O2. So now remember we also calculate what mass of O2 using what 48 grams of what O2, right? So the same thing. Now what you have done here, you're also going to repeat here. So mass of what CO2 equals to, now we are now using what 48 grams of what O2. 48 grams of what O2 over what 1. You get that? Times. Here we have division sign 2, right? So then now you're now using 64 grams of O2 equals to what 44 grams of what CO2. You get? So now because we're looking for what mass of CO2 here, so to move to the top, so it's going to be 44 grams of what CO2 over what 64 grams of what of O2. You get? Now the main reason why is like so gram of O2 cancel out the gram of what O2. Now when you do the calculation here, 48 times 44 divided by 64. Here we have two things here. Here we have 48 times 44 divided by what 64. Here we have 33. Here we have 33 grams of what CO2. Now, what does it tells you? It means that 48 grams of O2. It means that 48 grams of what O2 is equals to what 33 grams of what CO2. So with this one here, we can now get what our limiting what reactant and what reactant in what excess. So now what's the limiting reactant? Now the limiting reactant is the reactant that will produce the least amount of what of product. You get? So now here we have 44 grams of what O2. Here we have what 33 grams of what O2. Now which one is the least? 33 grams of what O2 is the least, right? Now which one produces what the least mass of O2 is what 48 grams of what O2. It means that because O2 produces what the least amount of what CO2, which is what the product, it means that O2 is the what limiting what reactant. Do you get that? What is what limiting reactant? You get? Now the reactant that produces the highest amount of what of the product is what is the reactant in what excess. Of course, methane produces what 44 grams of O2, which is what is the highest, right? Out of the two, it means that CH4 is the reactant in what excess. You get? It's very easy. Then what next again? Remember the question says she what calculate what the amount of the product produced, right? So the amount of the product produced is always what the least amount of the product produced in the what reaction. So here we have 44 grams. Here we have what 33 grams. 33 grams is what is the least amount. So it is what is the amount of CO2 that you produce. So it means that 33 grams of CO2 is formed. Do you get that? Is what form or what produce. So that is what you really want to take note of here. You get? So you can see that with this simple method here, you are going to treat things. One, you are going to what the limiting reactant, you are getting what the reactant essay, you also get what the amount of what of the product produced what in a what chemical what reaction. You get? So these are to what to get your limiting reactant and what reactant in what excess. So now in my future video, in the next video, we are going to solve more questions. So if this video is actually helpful, please subscribe to the channel if you have not done that and give it a like. Right? If you have any question, you can leave it at the comment section. You guys. Thanks for watching. See you in the next video.